Hello, in this lecture we will find out the value of angle ADC using two different methods. In the drawing we have triangle ABC. We know that angle ABC equals to 30 degrees. This angle ACB equals to 100 degrees, and we also know that side AD equals to side BC, and we want to find out the value of this angle ADC. So we'll start with the first method, and we will define side AC of triangle ABC as A, and we also will define side BC of triangle ABC as B, that is to say the length of side BC is equal to B units. So here BC equals to B units in its length, AC equals to A units in its length, and it is given us in the question that AD equals to BC, but according to our definition, BC equals to B units. So from this equation that AD equals to BC equals to B, we will derive that AD also equals to B. So I can write here that AD equals to B, and in the next step I will present to you a new law that is actually the law of cosines, the law of sines. The law of sines is true in any triangle. So I can write down that in any triangle, so if we have triangle ABC, that could be any triangle, again this is triangle ABC, and we know the side BC of triangle ABC equals to A units in its length. This angle is angle A. Side AC of triangle ABC equals to B units in its length, and this is angle B. And side AB of triangle ABC equals to C units in its length, and this is angle C. Then according to the law of sines, A over sine A equals to B over sine B, equals to C over sine C. Okay, I will repeat again. According to the law of sines, A over sine A equals to B over sine B equals to C over sine C. We conclude from this formula that A over sine A equals to B over sine B, and we will implement the law of sines in our triangle ABC. So I will copy this triangle ABC, and we will implement the law of sines on this triangle ABC. So So this is triangle ABC that I copied from the original image, from the original drawing. In triangle ABC we know that side AC equals to A units, side BC equals to B units, angle ABC equals to 30 degrees, and angle ACB equals to 100 degrees. We will find out the value of angle BAC. The value of this angle, we will define it as angle X. And we know that the sum of the angles in any triangle is equal to 180 degrees. So we will get that X plus 100 degrees plus 30 degrees must be equal to 180 degrees. We will subtract from this equation 130 degrees, and we will get that angle X equals to 180 degrees minus 150 degrees is 180 degrees minus 130 degrees is equal to 50 degrees. So we found out that angle X equals to 50 degrees, so we will substitute angle X by 50 degrees. From this angle BAC equals to 50 degrees. Now we will implement the law of sines on this triangle ABC. According to the law of sines, we will get that A over sine 30 degrees equals to B over sine 50 degrees. So here we will divide the equation number 1 by B, and then we will multiply it by sine 30 degrees, and we will get that according to equation number 1, A over B equals to sine 30 degrees over sine 50 degrees. In the next step, we will focus on triangle ADC, this triangle. We just right now found out that angle BAC, this angle equals to 50 degrees. So if we define angle DAB as theta, then the value of angle DAC must be equal to 50 degrees minus theta. So the value of this angle, that is actually angle DAC, it equals to 50 degrees minus theta. We will define angle ADC, the angle that we are looking for, as angle Y, and we know that the sum of the angles inside triangle ADC must be equal to 180 degrees. That is to say, angle Y plus 100 degrees plus 50 degrees minus theta must be equal to 180 degrees. Here we will subtract it is actually angle Y plus 100 degrees plus this angle that is actually 50 degrees minus theta must be equal to 180 degrees. So here we will subtract 150 degrees from this equation, and we will get that angle Y minus theta equals to 180 degrees minus 150 degrees is 30 degrees. So here we will add theta to this equation, and we will get that angle Y equals to 30 degrees plus theta. So the angle that we are looking for, that is to say angle Y equals to 30 degrees plus theta. So I will copy triangle ADC in a new page, and we will implement the law of sines in this triangle ADC. So actually, this is a triangle ADC that I copied from the original drawing. We know that angle DAC, this angle equals to 50 degrees minus theta. Angle ACD is 100 degrees, it is given as an equation, and we just right now found that angle ADC, the angle that we are looking for, equals to 30 degrees plus theta. So we will implement the law of sines in this triangle ADC. According to the law of sines, we will get that A over sinus 30 degrees plus theta will be equal to B over sinus 100 degrees. Here we will divide equation number 2 by B, and then we will multiply it by sinus 30 degrees plus theta, and we will get that A over B equals to sinus 30 degrees plus theta over sinus 100 degrees. And according to equation number 1, we've already found out that, that A over B equals to sinus 30 degrees over sinus 50 degrees. In the next step, we will create equation number 3 that states that A over B according to equation number 1 must be equal to A over B according to equation number 2. Okay? So actually, according to equation number 3, we will get that A over B according to equation number 1 is sinus 30 degrees over sinus 50 degrees. And it must be equal to A over B according to equation number 2. And A over B according to equation number 2 is sinus 30 degrees plus theta over sinus 100 degrees. Here we will cross multiply equation number 3 and we will get that first of all sinus 30 degrees is 1 over 2, so sinus 30 degrees times sinus 100 degrees equals to sinus 30 degrees plus theta times sinus 50 degrees. We will use the trigonometric identity that states that sinus 2a equals to 2 sinus a cosine a so we'll use this trigonometric identity for sinus 100 degrees, and according to this trigonometric identity we will get that sinus 100 degrees equals to 2 sinus 50 degrees times cosine 50 degrees and it equals to sinus 30 degrees plus theta times sinus 50 degrees. Here we have 2 over 2 is 1, so 2 will get cancelled. And we have sinus 50 degrees on both sides of equation number 3, so sinus 50 degrees will get cancelled. And what is left after we cancel sinus 50 degrees from equation number 3? What is left from equation number 3 is cosine 50 degrees equals to sine 30 degrees plus theta. Here we will use the trigonometric identity that states that cosine alpha equals to sine 90 degrees minus alpha. According to this trigonometric identity, we will get that cosine 50 degrees equals to sine 90 degrees minus alpha, that is 50 degrees. So we actually got that cosine 50 degrees equals to sine 90 degrees minus 50 degrees is 40 degrees. So we actually found out that cosine 50 degrees equals to sine 40 degrees. Now we will substitute cosine 50 degrees in this equation number 3, by sine 40 degrees. And we get that according to equation number 3, sine 40 degrees equals to sine 30 degrees plus theta. So if sine 40 degrees equals to sine 30 degrees plus theta, it means that 40 degrees equals to 30 degrees plus theta. Here we will subtract 30 degrees from this equation, and we will get that theta equals to 40 degrees minus 30 degrees is 10 degrees. So we actually found out that theta equals to 10 degrees. And the angle that we are looking for, it is actually 30 degrees plus theta, that is to say it equals to 30 degrees plus theta, that is 10 degrees, that is to say it equals to 40 degrees. So we actually found out that the angle that we are looking for, that is to say angle ADC, equals to 40 degrees. So we finished with the first method. In the next step, I will present to you how to find out the value of this angle ADC, according to the second method. So in the second method, we will define side BC of triangle ABC as A. That is to say, side BC equals to A units. And according to what is given us in the question, we know that AD equals to BC, but BC equals to A according to our definition. So from this equation that AD equals to BC equals to A, we will derive that AD also equals to A. So here AD equals to A. In the next step, we will extend side BC by a straight line. Then from point A, we will row perpendicular to the extended BC. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we will define the intersection point between the extended BC and the perpendicular from point A as E. And then we'll find out the value of angle ACE, the value of this angle. First of all, we know that BC is one side of triangle ABC, therefore it is absolutely a straight line. And then after we extended the straight line BC by a straight line, it still must be a straight line. So actually we found out that BE is a straight line. I will write it down. BE is a straight line. Line segment BE is a straight line. And we know we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BE at point C, the sum of the angles must be equal to 180 degrees. So at point C we have this angle that is equal to 180 degrees plus the size of this angle that we will define as angle Y. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. So we write down that 100 degrees plus the size of angle Y must be equal to 180 degrees. Here we will subtract 100 degrees from this equation and we will get that angle Y equals to 180 degrees minus 100 degrees. That is to say angle Y equals to 80 degrees. Okay, so we found out that angle Y equals to 80 degrees, so we can write here that angle Y equals to 80 degrees. In the next step, we will define line segment AE or side AE as Y, that is to say AE equals to Y units in its length, and we will define line segment CE as X, that is to say the length of line segment CE is equal to X units, and we will focus on the right triangle ACE. In the right triangle ACE, tangents 80 degrees equals to AE over EC. So I'll repeat again. In the right triangle AEC, the right triangle AEC, we know that tangents 80 degrees equals to AE over EC. But according to our definition, AE equals to Y and EC equals to X. So actually in conclusion, we found out that tangents 80 degrees equals to Y over X. Tangents 80 degrees equals to Y over X. Here we will multiply equation number 1 by X and we will get that X times Y equals to X times tangents 80 degrees. I'll repeat again, according to equation number 1, Y equals to X times tangents 80 degrees. In the next step, we'll focus on the right triangle ADE. But before that, we will define the angle that we are looking for, that is to say angle ADC or angle AD, it is the same as angle theta. And in the right triangle ADE, we know that sinus theta equals to AE over AD. AE over AD I repeat again, in the right triangle AD, sinus theta equals to AE over AD. But according to our definition, AE equals to Y, and we have already found out that AD equals to A. So actually, in conclusion, we found out that according to equation number 2, sinus theta equals to Y over A. I repeat again, according to equation number 2, sinus theta equals to Y over A. Here we will multiply equation number 2 by A, and then we will divide it by sinus theta, and we will get that A equals, according to equation number 2, A equals to Y over sinus theta. But according to equation number 1, Y equals to X times tangent 80 degrees, so we will substitute Y in equation number 2 by X tangent 80 degrees, and we will get that A equals to Y, that is X tangent 80 degrees, over sinus theta. I'll repeat again, according to equation number 2, A equals to X times 80 degrees over sinus theta, and according to equation number 1, Y equals to X times tangent 80 degrees. In the next step, we will focus on triangle ABE. On the right triangle, triangle ABE, we know that tangent 30 degrees equals to AE over BE. I repeat again, in the right triangle, triangle ABE, tangent 30 degrees equals to AE over BE. But according to our definition, AE equals to Y, and BE equals to A plus X. Therefore, according to equation number 3, we will get that tangent 30 degrees equals to Y over A plus X. I repeat again, according to equation number 3, tangent 30 degrees equals to Y over A plus X. Here we can substitute Y by X tangent 80 degrees, and we can substitute X by, we can substitute A by X tangent 80 degrees over sinus theta, because of the fact that A equals to X tangent 80 degrees over sinus theta. So we will do it now, and we will get that according to equation number 3, tangent 30 degrees equals to Y is X tangent 80 degrees, according to equation number 1. Over A plus X, and A, according to equation number 2, is X times tangent 80 degrees over sinus theta, and we also have to add to equation number 3 X. Actually, we will add, we will multiply X by sinus theta, and then we will divide it by sinus theta, so we change nothing. So here we will move sinus theta that is located in the denominator to the numerator, and we will get that according to equation number 3, and we also know that tangent 30 degrees is 1 over square root of 3 units, and it will be equal to x tangent 80 degrees times sinus theta divided by x tangent 80 degrees plus x sinus theta. So here we have x in the numerator and we have x in the denominator, so x will get cancelled. In the next step, we cross multiply equation number 3, and we will get that x is cancelled, so we have only tangent 80 degrees plus sinus theta equals to square root of 3 times tangent 80 degrees times sinus theta So here we will subtract sinus theta from this equation, equation number 3, and we will get that according to equation number 3, tangent 80 degrees equals to square root of 3 times tangent 80 degrees times sinus theta minus sinus theta. So here we will take a common factor of sinus theta out of this side of equation number 3, and we will get that tangent 80 degrees equals, from here we will take sinus theta as a common factor, so inside the brackets what is left from square root of tangent 80 degrees times sinus theta, after we took from it sinus theta as a common factor, what is left is actually square root of 3 times tangent 80 degrees. And what is left from minus sinus theta after we took it from it sinus theta as a common factor, what is left, it is actually minus 1. So here we will divide this equation, equation number 3 by square root of 3 times tangent 80 degrees over 1, and we will get that according to equation number 3, sinus theta equals to tangent 80 degrees tangent 80 degrees over square root of 3 tangent 80 degrees minus 1. So here we have tangent 80 degrees in the numerator and we have tangent 80 degrees in the denominator. So we will substitute tangent 80 degrees by sinus 80 degrees over cosine 80 degrees. We'll do it now and we will get that according to equation number 3, sinus theta equals to tangent 80 degrees is sinus 80 degrees over cosine 80 degrees all divided by square root of 3, and we have tangent 80 degrees. It is actually sinus 80 degrees over cosine 80 degrees. And we also have to subtract 1, so we will multiply minus 1 by cosine 80 degrees and then we will divide it by cosine 80 degrees. So here we have cosine 80 degrees in the numerator and we have cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled. And what is left from equation number 3 after we cancel cosine 80 degrees? What is left actually is that in this side of equation number 3 we have sinus theta that equals to sinus 80 degrees over square root of 3 times sinus 80 degrees sinus 80 degrees minus cosine 80 degrees So here we will multiply the denominator on this side of equation number 3 by 2 and then we will divide it by 2 and we will get that sinus theta equals to sinus 80 degrees So we will multiply the denominator of this set of equation number 3 by 2 and then we will divide it by 2 minus cosine 80 degrees okay. So according to equation number 3 we will get that sinus theta equals to sinus 80 degrees over 2 times sinus 80 degrees and we will substitute square root of 3 over 2 by cosine 30 degrees. Here we will substitute 1 over 2 by sine 30 degrees, because sine 30 degrees is 1 over 2 times cosine 80 degrees. So actually this expression is very similar to the trigonometric identity that states that sinus A times cosine B minus sinus B cosine A so it is the sinus B times cosine A that equals to sinus A minus B. Actually, our expression sinus 80 degrees times cosine 30 degrees minus sine 30 degrees times cosine 80 degrees is very similar to the trigonometric identity that states that sinus A times cosine B minus sinus B times cosine A equals to sinus A minus B. So we will substitute our expression by sine A minus B. In our specific expression, A equals to 80 degrees and B equals to 30 degrees. So we will get that according to equation number 3, sinus theta equals to sinus 80 degrees over 2 times, and we substitute our specific expression by sine A minus B, and in our specific expression A equals to 80 degrees and B equals to 30 degrees. So in conclusion, we found out that according to equation number 3, sinus theta equals to sinus 80 degrees over 2 times sinus 80 degrees minus 30 degrees, and 30 degrees minus 80 degrees minus 30 degrees is 50 degrees, so I write it down. So according to equation number 3, we will get that sinus theta equals to sinus 80 degrees over 2 and over 2 times sine 50 degrees. We will use the trigonometric identity that states that sine 2a equals to 2 sine A cosine A. So according to this trigonometric identity, we will get that sinus 80 degrees equals to 2 sinus 40 degrees times cosine 40 degrees. And we have to divide it by 2 sine 50 degrees. So here 2 over 2 is 1, so 2 will get cancelled. And we will use the trigonometric identity that states that sine alpha equals to cosine 90 degrees minus alpha. We will use this trigonometric identity. Actually, according to this trigonometric identity, we will get that sinus 50 degrees equals to cosine 90 degrees minus 50 degrees. So actually, sinus 50 degrees equals to cosine 90 degrees minus 50 degrees is 40 degrees, so it is cosine 40 degrees. So we actually found out that sine 50 degrees equals to cosine 40 degrees, so we will substitute sine 50 degrees in this equation number 3, by cosine 40 degrees. We will do it now and we will get that according to equation number 3, sinus theta equals to sinus 40 degrees times cosine 40 degrees over, I repeat again, we will substitute sine 50 degrees in this equation number 3, by cosine 40 degrees, because they are equal to each other. So cosine 40 degrees over cosine 40 degrees is 1, so cosine 40 degrees will get cancelled. And we found out that according to equation number 3, sinus theta equals to sinus 40 degrees, that is to say, theta equals to 40 degrees. Theta equals to 40 degrees, and our missing angle, the angle that we are looking for, is angle ADC that equals to theta. So the angle that we are looking for, that is ADC, equals to angle theta that equals to 40 degrees. So we found out that the angle that we are looking for, that is to say angle ADC, equals to 40 degrees. Okay, so in both methods, we found out that the angle that we are looking for, that is to say angle ADC, equals to 40 degrees. In the next step, I will summarize the lecture. Actually, we found the value of angle ADC in 2 different methods. In the first method, we defined side AC as A and side BC as B. According to what is given us in the question, AD equals to BC. But according to our definition, BC equals to B units. So from this equation, AD equals to BC equals to B, we will derive that AD also equals to B. So we write down that AD equals to B. We wrote here that AD equals to B. And then I presented to you a new law, that is the law of sines. According to the law of sines, in any triangle, if we have this triangle ABC, that could be any triangle, and we know that side AB of triangle ABC equals to 3 units, side AC equals to B units and side BC equals to A units. This is angle A, this is angle B, this is angle C. Then according to the law of sines, we will get that A over sine A equals to B over sine B equals to C over sine C. And it is true in any triangle. From this formula we will derive that A over sine A equals to B over sine B. So we can implement the law of sines in our triangle ABC. So I actually copied triangle ABC in this new page from the original drawing. Here we know that angle ABC equals to 30 degrees, angle ACB equals to 100 degrees, and this is the missing angle, so we defined it as angle X, and we know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, angle X plus 100 degrees plus 30 degrees must be equal to 180 degrees. Here we subtracted 130 degrees from this equation, and we found out that angle X equals to 180 degrees minus 130 degrees is 50 degrees. So this angle BAC equals to 50 degrees. Again, we know that AC equals to A and BC equals to B, so according to the law of science, we will get that A over sine 30 degrees equals to B over sine 50 degrees. This is equation number 1. Here we divided equation number 1 by B, and then we multiply it by sine 30 degrees, and we got that A over B equals to sine 30 degrees over sine 50 degrees. Okay, then we focused on triangle ADC. This triangle ADC, we just right now found out that angle BAC, this angle equals to 50 degrees. So if we define angle BAD as theta, then angle DAC must be equal to 50 degrees minus theta. That is to say, angle DAC equals to 50 degrees minus theta. This angle equals to 100 degrees, and this angle is the missing angle. So according to the rule that the sum of the angles in any triangle is equal to 180 degrees, we will get that this angle that is actually equals to 50 degrees minus theta plus 100 degrees plus this angle that we defined as angle Y must be equal to 180 degrees. Here we subtracted 150 degrees from this equation, and we found out that Y minus theta equals to 180 degrees minus 150 degrees is 30 degrees. So Y minus theta equals to 30 degrees. We added theta to this equation, and we found out that Y equals to 30 degrees plus theta. So the angle that we are looking for, that is actually angle ADC, equals to 30 degrees plus theta. Then I copied this triangle ADC in the new page, and we implemented the law of sines in this triangle ADC. So here in triangle ADC, we know that angle DAC equals to 50 degrees minus theta, angle ACD equals to 100 degrees, and the angle that we are looking for, angle ADC, equals to 30 degrees plus theta. So we implemented the law of sines in this triangle ADC. According to the law of sines, we will get that A over sinus 30 degrees plus theta equals to B over sinus 100 degrees. Here we divided equation number 2 by B, and then we multiply it by sine 30 degrees plus theta, and we got that A over B equals to sine 30 degrees plus theta over sine 100 degrees. This is according to equation number 2, but according to equation number 1, A over B equals to sine 30 degrees over sine 50 degrees. Then we created equation number 3 that states that A over B according to equation number 1 must be equal to A over B according to equation number 2. So, according to equation number 3, A over B according to equation number 1 is sinus 30 degrees over sinus 50 degrees, and A over B according to equation number 2 is sinus 30 degrees plus theta over sinus 100 degrees. So A over B according to equation number 1 must be equal to A over B according to equation number 2. Here we multiply this equation number 3, and we know that sinus 30 degrees is 1 over 2. So we got that 1 over 2 times sine 100 degrees equals to sine 30 degrees plus theta times sine 50 degrees. Here we used the trigonometric identity sinus 2a that equals to 2 sine a cosine a in order to simplify sine 100 degrees. Sine 100 degrees according to this trigonometric identity will be equal to 2 sine 50 degrees times cosine 50 degrees. 2 over 2 will get cancelled, and here it equals to sine 30 degrees plus theta times sine 50 degrees. So we have sine 50 degrees in both sides of the equation, so sine 50 degrees will get cancelled. And we left only with cosine 50 degrees that equals to sine 30 degrees plus theta. We use the trigonometric identity that cosine alpha equals to sine 90 degrees minus alpha. According to this trigonometric identity, we will get that cosine 50 degrees equals to sine 90 degrees minus 50 degrees. 90 degrees minus 50 degrees is 40 degrees. So we have here cosine 50 degrees that equals to sine 40 degrees. Okay, so here we will substitute cosine 50 degrees by sine 40 degrees because they are equal. We did it here in equation number 3, and we got that sine 40 degrees equals to sine 30 degrees plus theta. It means that 40 degrees equals to 30 degrees plus theta. We subtracted 30 degrees from this equation number 3, and we found out that angle theta equals to 40 degrees minus 30 degrees is 10 degrees. So angle theta equals to 10 degrees, but the angle that we are looking for is equal to 30 degrees plus theta. That is to say, angle ADC that equals to 30 degrees plus theta, and theta is equal to 10 degrees, will be equal to 40 degrees because of the fact that 30 degrees plus 10 is 40 degrees. So we found out that according to the first method, the angle that we are looking for, that is to say angle ADC equals to 40 degrees. Then I presented to you how to find out the value of angle ADC according to the second method. In the second method, first of all, we defined BC as A, that is to say BC equals to A units in its length, and according to what is given us in the question, AD equals to BC. But according to our definition, BC equals to A. So from this equation, AD equals to BC equals to A, we will derive that AD also equals to A. Here AD also equals to A. Then we extend that side BC by a straight line, and from point A we drew perpendicular to the extended BC. So this angle is 90 degrees and this angle is 90 degrees. We defined the intersection point between the perpendicular from point A and the extended BC as point E. Then we found out the value of angle ACB. We know that BC is one side of triangle ABC, therefore it is absolutely a straight line. And then when we extended the straight line BC by a straight line, it will be still a straight line. CBE, that is the extended BC, will be still a straight line because we extended the straight line by straight line. So we can write down that BE is a straight line, and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BE at point C, then the sum of the angles must be equal to 180 degrees. Which angles we have in the upper side at point C? We have 100 degrees, and this angle is angle Y. And according to the rule that I mentioned, 100 degrees plus angle Y must be equal to 180 degrees. We subtracted 100 degrees from this equation, and we found out that angle Y equals to 180 degrees minus 100 degrees is 80 degrees. So angle Y equals to 80 degrees. Then we focused on the right triangle, triangle ACE. In the right triangle, triangle ACE, we know that tangents 80 degrees equals to AE over AC. Tangents 80 degrees. In the right triangle, triangle AEC, tangents 80 degrees equals to AE over AC. But according to our definition, AE equals to Y and EC equals to X. So we got that tangents 80 degrees equals to Y over X. We multiplied this equation number 1, by X, and we found out that Y equals to X times tangents 80 degrees. Then we focused on the right triangle, triangle ADE, and we defined the angle that we are looking for, that is to say angle ADC as theta. And in the right triangle, triangle ADE, we know that sinus theta equals to AE over AD. Sinus theta in the right triangle ADE, sinus theta equals to AE over AD, but AE equals to Y and AD equals to A, according to our definition. So we found out that sinus theta equals to Y over A. Here we multiplied the equation number 2 by A, and then we divided by sinus theta, and we got that A equals to Y over sinus theta. Okay? And according to equation number 1, Y equals to X tangents 80 degrees. So here Y over sinus theta will be equal to X tangents 80 degrees over sinus theta. This is according to equation number 2, and according to equation number 1, Y equals to X tangents 80 degrees. Then we focus on the right triangle, triangle ABE. On the right triangle, triangle ABE, we know that tangents 30 degrees equals to AE over BE. In the right triangle, triangle ABE, we know that tangents 30 degrees equals to AE over BE. AE equals to Y, according to our definition. And BE equals to A plus X. Okay? Therefore, tangents 30 degrees equals to Y over A plus X. According to equation number 1, Y equals to X tangents 80 degrees. And A equals to X tangents 80 degrees over sinus theta. So we substituted Y by X tangents 80 degrees here, and we substituted A by X tangents 80 degrees over sinus theta. And here we also add X. So we multiplied X by sinus theta, and then we divided by sinus theta, so we changed nothing. Here we moved sinus theta from the denominator to the numerator, and we got that here tangents 30 degrees is 1 over square root of 3. So in conclusion, we found out that X times tangents theta times X times tangents 80 degrees times sinus theta equals to X tangents 80 degrees plus X sinus theta. We have X in the numerator and X in the denominator, so X will get cancelled, and we got that according to equation number 3, tangents 80 degrees plus sinus theta equals to square root of 3. Actually here we multiplied this equation number 3, and we found out that tangents 80 degrees plus sinus theta equals to square root of 3 times sinus theta times sinus theta. Here we subtracted sinus theta from this equation number 3, and we found out that tangents 80 degrees equals to square root of 3 times tangents theta times sinus theta minus sinus theta. Here we took a common factor of sinus theta out of this expression, and we found out that tangents 80 degrees equals to sinus theta, and sinus theta is a common factor. Inside the brackets, what is left here, square root of 3 times tangents 80 degrees, and what is left from minus sinus theta after we took from it sinus theta, what is left is actually 1. So in conclusion, we found out that tangents 80 degrees equals to sinus theta times square root of 3 times tangents 80 degrees minus 1. Here we divided this equation number 3, by square root of 3 times tangents 80 degrees minus 1. And we found out that sinus theta equals to tangents 80 degrees over square root of 3 times tangents 80 degrees minus 1. Here we substituted tangents 80 degrees by sinus 80 degrees over cosine 80 degrees. So we got that sine 80 degrees equals to tangent 80 degrees, but tangent 80 degrees is sinus 80 degrees over cosine 80 degrees divided by square root of tangent 80 degrees. But tangent 80 degrees is sinus 80 degrees over cosine 80 degrees, and we have also to subtract 1. So we substituted 1 by minus cosine 80 degrees by cosine 80 degrees. Minus 1 equals to minus cosine 80 degrees over cosine 80 degrees. Here we have cosine 80 degrees in the numerator and we have cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled. After we cancelled cosine 80 degrees, we left with sinus theta that equals to sinus 80 degrees over square root of 3 times sinus 80 degrees minus cosine 80 degrees. Then we multiplied the denominator of this expression by 2 and then we divided by 2. And we found out that sinus theta equals to sinus 80 degrees over 2 times square root of 3 divided by 2 times sinus theta minus cosine theta, that is actually divided by 2. Cosine theta it is actually cosine 80 degrees divided by 2. Because actually what we did is we multiplied the denominator by 2 and then we divided by 2. So here we multiplied by 2 and then here we divided by 2. Here we multiplied it by 2 and then here we divided by 2. So we changed nothing. So we got that sinus theta equals to sinus 80 degrees, and we know that square root of 3 over 2 is cosine 30 degrees minus cosine 80 degrees over 2. But 1 over 2 is sine 30 degrees, and we have also cosine 80 degrees. So we substituted 1 over 2 by sine 30 degrees here, and here we substituted square root of 3 over 2 by cosine 30 degrees. But this expression, sine 80 degrees times cosine 30 degrees minus sinus 30 degrees times cosine 80 degrees is very similar to the trigonometric identity that states that sine A times cosine B minus sine B times cosine A equals to sine A minus B. It means that we can substitute our expression by sine A minus B. We did it, and in our specific expression A equals to 80 degrees and B equals to 30 degrees. So we did it and we got that sinus 30 degrees equals to sinus 80 degrees, sinus theta equals to sinus 80 degrees over 2 times sine A is 80 degrees and B is 30 degrees. So it is sinus 80 degrees minus 30 degrees. And we got here that sinus theta equals to sinus 80 degrees over 2 times sinus 80 degrees minus 30 degrees is 50 degrees. So it is 2 times sine 50 degrees. Then we use the trigonometric identity that states that sinus 2a equals to 2 sine a cosine a in order to treat sine 80 degrees. And according to this trigonometric identity, we will get that sinus 80 degrees equals to 2 sine 40 degrees times cosine 40 degrees. So in conclusion, we got that according to equation number 2, sinus theta equals to 2 sine 40 degrees cosine 40 degrees over 2 sine 50 degrees. Here 2 over 2 will get cancelled. And according to the trigonometric identity that sinus alpha equals to cosine 90 degrees minus alpha, we will get that the value of sinus 50 degrees equals to cosine 90 degrees minus 50 degrees. That is to say, sinus 50 degrees equals to 90 degrees minus 50 degrees is 40 degrees. So sinus 50 degrees equals to cosine 40 degrees. Okay? So it means that we can substitute sinus 50 degrees in equation number 3 by cosine 40 degrees because they are equal to each other. We did it here and we got that sinus 30 degrees, sinus theta equals to sinus 40 degrees times cosine 40 degrees over cosine 40 degrees. Cosine 40 degrees over cosine 40 degrees is 1. So cosine 40 degrees will get cancelled. and we left only with sine theta that equals to sine 40 degrees. That is to say, theta equals to 40 degrees. And angle theta, it is actually the angle that we are looking for. That is to say, it is angle ADC. So angle ADC equals to angle theta, that equals to 40 degrees. So we found out in both methods that the value of the angle that we are looking for, the value of angle ADC, the value of angle ADC equals to 40 degrees. Okay, thank you very much.